Hey class, some people have been asking questions on a couple of the homework problems, so I was going to give you two examples here from two different questions of really just how to get started on these problems dealing with Bernoulli's principle. So here we have this question where we have this weird tunnel that prairie dogs have made, and in fact prairie dogs and other ground living animals will intentionally design their underground systems to be able to create pressure differences so air will flow through so that they don't suffocate, which is kind of wild and a cool thing of engineering and physics mastery that prairie dogs seem to take advantage of, or really that God bestowed in them, I believe. Anyway, so here we have a situation where we have two different openings that will experience two different flow speeds of air over the tops of them. And in this case, we're lucky in that the two tops are at the same vertical level, although if their vertical levels were different, it wouldn't be that much trickier to deal with. Anyway, if we want to use Bernoulli's, much like when we use the principle of conservation of energy, you need to start by identifying kind of position or situation one, position, location, situation two, that you will be comparing when you use Bernoulli's. So in this case, I'm going to go ahead and call situation or location A number one and location B number two. And then the next thing you need to think about is identifying which forms of energy per unit volume are present at each of those. So in both cases, we have a velocity, so there's going to be this kinetic energy per unit volume term, and then we're asked to find the pressure difference. So if we think about the pressure difference between those two, I think of delta P as being equal to P1 minus P2, or P2 minus P1, but I know that the pressure at point 1 is going to be the larger, so to get a positive value for my pressure difference, I'm going to look at P2 minus P1. So I'm given the V value and the density values, so I can find these guys here, and I identify that they're at the same height. So if I go ahead and call this height that they both are at the 0 location in the vertical scale, that means H1 is 0, and H2 is also 0, so these terms go away, and so you should be able to simply solve by getting your pressures on the same side and your kinetic energy per unit volumes on the same side. P1 minus P2 equals 1/2 rho V2 squared minus 1/2 rho V1 squared, and I can let you run from there, but again, this here is the delta P that you're being asked to solve for. So again, it's much like conservation of energy, where you start out with Bernoulli's equation, identifying your 2 points, and then you work from there. If we move into this other question that's also on the homework here, this is the last one on this homework assignment. We're given this scenario where you have like this kind of lake of water, all right, and there's going to be, or a reservoir, I guess, and there's going to be a pump with an intake down at the bottom. So here's our intake. It's a distance h below the surface. In this case, h is 18 meters. And then water is going to be flowing in there, and it tells you that it's going to flow in at some speed v. So if we call this like location 2, v2 equals some number, and that's what you're being asked to find. But we're given this weird scenario where it says, what is the maximum possible speed that v2 can be? So in this case, we needed to choose 2 points. Now this one, it's not as obvious. The other one, it gave us A and B. Here we know that there's this intake that we need to consider, but what would point 1 be if I'm calling that point 2? Well, for me, the only other spot that we really know anything about is the distance that's h above the intake, which is the surface of the water. Because at this point, we know that the pressure is just atmospheric. And if we define this height as our 18 meters, that would be h1, and that would make the height down here, h2, equal to 0. So if we go through our equation, we know P1 is just atmospheric pressure. V1, what is the speed of the water at the surface? Well, this is one of those ones that sometimes messes with people, right? But when we have this giant reservoir that we don't even know the width of, in comparison to the intake at this little pipe, you can assume when you have a large body of water like this that the relative speed of the overall body of water is going to be approximately equal to 0. There will be, I guess, a little bit of movement if you're draining the entire lake as it slowly moves down, but it's going to be like 0.000001 meters per second, which can be approximated to be 0. So this term would be 0, and then we have plus rho g h1. Now when we get to the other side, we know h2 is 0, v2 is what we're trying to solve for, the density is the density of water, so all we're left with is what about p2? Without p2, we can't really solve. And so this is one of the big tricks. It asks you what is the maximum possible speed. So if we want to find the maximum possible speed, we need to ask ourselves what p2 would give us the biggest possible speed. Well, that's going to be when P2 is its very smallest, and the very smallest P2 can be is when you have a perfect vacuum, which would make P2 0. So if you set it to the smallest possible value, then you can go ahead and solve for the maximum speed of V2 by using this derived equation from Bernoulli's principle. Hope that helps you all. Have yourselves a box-worthy evening, and I'll see you all in class.